Okay, so yeah, the C in Q equals MC delta T is specific heat, and that's why water heats up slow, cools off slow, but concrete would heat up fast and cool off fast. So I'm going to come back to that. I'm going to explain when we use these and why we use these and what this is all about. Then we'll talk more about that specific heat, and then we'll talk about the boiling water in the pot. This has more variables than this. What does this have that this doesn't have?
Specific heat.
C, specific heat. What else?
Change, delta.
Change in?
Temperature.
Temperature, right. What's M stand for? It's right on the back of the reference tables. You don't need to memorize any of this. Someone just said it anyway. Mass. That's the mass. What's Q stand for? On the back of the reference tables. Heat. So why does this exist? In chemistry, sometimes we want to know how much heat it takes to heat something, or how much heat it loses when it cools down. So that's why these exist, but there's 3 different equations for 3 different scenarios. So I'm going to tell you what they are. So write this down. This one is for heat changes in one phase of a substance. So if you heat or cool a substance while it's in one phase. That's kind of a confusing way to explain it, but that's exactly what it means. So if you have liquid water, solid water, ice, or water vapor, and you heat or cool down the ice, the water, or the vapor, and it does not change phase, it stays ice, it stays water, it stays vapor, that's this one. These 2 are for phase changes. These are for phase changes. Q equals MHF, Q equals MHV are for 2 different phases. HF is for melting or freezing. So if you ever come across a question, you will tomorrow in class. Oh, I forgot to tell you, some of you know, I won't be here tomorrow. I might have told you the other day, I don't know. But I got a conference tomorrow, so you'll be doing 2 worksheets, one in class, one's for homework. So I'm going to have you do the worksheet in class first. When that's done, you're going to hand it in and get the homework. If you get that done in class, you have no homework.
Where's your conference?
Latham.
Can I come?
For what though?
AP Chemistry.
Oh.
So you're going to see questions where you have to use all 3 of these tomorrow. This one's more common. Okay, I'm going to give you a lot more on those, on this, but you're going to have a couple of these. So if the question talks about freezing or melting, you're using this one. This equation is for boiling. And I always find it easier, kids find it easier for this one, because what is HV? What does it stand for on the back of the reference tables? What does HV stand for? Heat of vaporization. What does vaporization sound like? Sounds like boiling. Evaporating, right? So vaporization is for boiling. What's HF stand for? Heat of fusion. In chemistry, fusion means a couple things. One of them is melting. Fusion means melting. It also means kind of putting things together. That's nuclear stuff. That's different. So heat of fusion is for melting. Heat of vaporization is for boiling. So again, tomorrow you're going to see, I'm not going to get to this today in class. We don't have time. So tomorrow you're going to give it a shot, see how you do. We'll go over it Monday. But this one, we'll get at least one example today. And you should have been able to do a little bit of these are the worksheets up here on Monday. Hopefully a little bit of it made some sense, hopefully. So these are the equations for heat, and this is when we use them. Last thing I want to write down is the numbers or the values for these things. I'm going to tell you what C, HF, and HV are. We're going to write them down, but they're on your reference tables. And I just want to talk about them a little bit. So the specific heat of water is 4.18 joules per gram Kelvin. I'm going to explain what that means after this, like what all those units mean. So that's big. That's a huge specific heat. In fact, most substances on the planet have a lower specific heat than water. Water's is pretty hot, meaning what Ryan said. It heats up, and you know I'm letting you sit there.
What?
I'm letting you sit there. I just want to make sure. I'm letting you. I'm not giving
Oh
you
yeah, you're not gonna remember in your car ride home.
I think you just noticed just
No,
now.
I did.
said it earlier.
No, I said it earlier.
And his car ride home, he's
I wanna
like,
make it
oh
clear to him.
dang.
Well, when you get older and have a real job, you'll realize
I have a
when you
real
go
job.
home, you think about your job sometimes. It's
I
not
have
that
a,
weird. It's
I
not
have a
weird.
real job.
Just thinks about you.
What is it?
Do you get pumped
I
up
worked
for
at
the
Price
first
Chopper.
job and listen
No,
to
no, no. A
music?
job you can live off of.
Well, when they up it to $15 an hour, I couldn't live.
If that's your goal, then you got to
It's not my
reassess your
goal.
goals. All right, here we go.
What?
HF and HV. Now, that's specific heat of water, anyways. HF, heat of fusion. Table B. Go to table B, please. Table B. Now, I have it memorized because this is what I do for a living. I teach chemistry, right? I have it memorized. You don't have to have it memorized. But it's 334 joules per gram. That's the unit on HF. We will talk more about that on Monday. HV, 2260 joules per gram. Yes, I want you to copy them down. I know they're on the reference table. Copy them down anyway. Notice how this number is way bigger than that number. Almost 7 times bigger-ish, right? So it's a lot bigger. We'll talk about why heat of vaporization is so much bigger than the heat of fusion, right? Why is boiling so much bigger than melting? Maybe some of you already can make sense of it, but we'll talk about that. So anyways, those numbers are right on table B for you. You don't have to memorize it, okay? So tomorrow, when you're doing these worksheets, you got them on the table. You don't have to memorize it, all right? So now, let me explain specific heat a little bit, and then we'll move on here. How much time we got? We got enough time here? Yeah. Oh, you know what? I almost forgot. I got to get back your quizzes, finally. I forgot to do that. So, specific heat capacity. Specific heat capacity. All right, what is specific heat capacity? Here's the definition. It's the amount of heat or energy in joules needed to raise the temperature of 1 gram of a substance 1 Kelvin or 1 degree Celsius. So go ahead and copy it, then we'll make sense of it, 'cause it sounds confusing. Sorry, I'm looking something up here. It'll help you understand a little bit better. If I can find it quick. Whoops. All right, back to this. What does this mean? Well, if I'm holding a gram of water, how many joules do I have to give it to raise the temperature 1 degree Celsius? You all know the answer. You just wrote it down.
Can you ask it again?
I'm holding 1 gram of water, which I would only need one hand. 1 gram of water. How much energy would I have to give it to raise the temperature 1 degree? That's what this question. That's what this is saying. If I have 1 gram of water, how much heat do I need to heat it 1 degree?
Oh,
4.18 joules. That's how much. That doesn't make any sense to you. You can't relate it. You don't even know what that means. A banana, that's what I just looked up. A banana has about 380 kilojoules.
You got banana on there? That computer?
I just looked up how many joules are in a banana.
Did you?
Yes.
I
So
don't know why it's funny.
380 kilojoules are in a banana. So how many joules is that?
280. What did you just say?
Wait, kilojoules?
Yes.
Oh, kilojoules.
So that's 380,000, right?
What?
3,400,000.
Can you write the original number
Picture
down?
of the banana.
Wrong.
Yep.
Yeah, can you show us a picture of the banana so we can better understand it?
I think that answer's wrong. I had these written down and I lost them.
Well, let's pick an apple. Apples are easier.
No, bananas.
Apples are the nearest state fruit. We should pick
I think that bananas are the way to go.
Empire State Apple, right?
Yeah, you know what? I'll have to look it up again. These are not making any sense. So I'll talk to you Monday about it. I apologize. I'm trying to get you to understand that if you have certain foods have a certain amount of energy in them, and that's kind of where this comes from. Joules, calories. You guys know about calories, right? You're supposed to get, I don't know, it changes depending on the person, but 1,500, 2,000 calories a day or whatever. So what are the calories for? Energy. Joules are basically the same concept as calorie. So how many calories of heat, how many joules of heat do you need to give something to increase the temperature? That's what specific heat is all about. So if water is 4.18, but the concrete is like 0.5, that should make sense to you. It takes 4 joules to increase the water 1 degree, but it takes half a joule to increase the concrete 1 degree. This is why concrete heats up fast, cools down slow. Water heats up, I said that backwards. Heats up fast, cools down fast. This heats up slow, cools down slow. Because it takes more energy to gain and takes more energy to lose. So what I'm doing back here with the pot, I'm boiling the water, and when the water reaches the boiling point, I'll go back there and grab it. And if you were to touch the pot and touch the water, either one, while it's boiling, would you burn yourself? Yes. If I pour the water out of the pot, let the water sit, let the pot sit separately. After 5 minutes, which one do you think you can touch?
The water.
We'll try. If someone wants to stick their hand in the
The
water,
pot.
God bless you. So, which one should cool down faster?
The table that the water was on.
No, you only have 2 options: water or pot.
Well, the pot, because concrete.
Well, we'll find out. We're gonna do it. We'll find
Because
out.
on a
okay?
Thursday on a full moon,
What I'm saying is.
when the North Star is pointing south, the table cools down fast. That is my final answer. I'm locking it in.
Are you
The
done?
North Star. It's gotta be what?
So I'm gonna get that in a second here. While I'm back there doing that, and I gotta hand out your quizzes, but I'm gonna give you a sample problem. You're gonna use Q equals MC delta T. Let's see if you can get it started before I go over it. And then that's probably all we're gonna have time for today. So here we go. Write this down. How many joules of heat will 25 grams of water absorb if it is heated from 20 degrees Celsius to 80 degrees Celsius? That's your question. You are going to use Q equals MC delta T for 2 reasons. One, it's all water, which means liquid, right? We say water, we think liquid. It's not vapor, it's not ice. It's all water, so it's all one phase, and you're just heating it. You're not changing phases. So that's how we know it's this equation. The other way we know is it gives you 2 temperatures. If you're given 2 temperatures, that means there's a change in temp. That's the only equation with delta T. So that's another clue as to know, I use this equation. What I recommend you doing while I go back and look at that, and I gotta get some other stuff together here, I want you to do this on your paper. Fill in the variables and then plug them in, and you're gonna solve. What are we solving for? How many joules? Joules is a measurement of heat. So X goes here, or a question mark. We don't know Q.
Q is you.
Q is joules, yes. Yep, Q is joules. That's a good way to put it. Okay, these 3 numbers you have or you'll be able to figure out. So I'm gonna give you a couple minutes while I go get that situated here.
And you're just multiplying them or something?
Yeah, you're gonna plug them in that equation and multiply, yep. Do your best.
Yeah.
Allie, turn on the stir.
I don't want to multiply that out.
You need something fast. I don't know why I wasn't running.
What?
It's 25 times 25.
I'm master.
I asked her what it is that is not what it actually is.
I want a prestige. You can prestige with all these. You get to keep a combo.
What?
If you don't fold it, you get to keep one of those and become forever. There's one that gives you all the perks in there.
You just get it every game.
Yeah, but you couldn't do that because if you like spin it, you know how there's a thing where you like kind of get gum balls? If you spin it, and you get that's the best one. Like, the one they call it. That's the best one. If you get that and you use it, it goes right there eventually.
Are you done?
Yeah.
It goes right to the good part. If you prestige and you select that one,
So, see that
you
equation?
keep it no matter what. Like you can use it every game. Which is pretty cool. I've only gotten it once. I got it once. It's pretty cool.
Yeah. Can you go back up there? If you have a real concept or question to talk about, fine. Just being foolish. Why don't you talk to you?
Zach, is it possible for the North Star to point south?
Yeah. The North Star is always north, unless it's south. So it could be south.
That's interesting.
Pair up. Compare your answer.
Hold on.
Pair up.
I didn't find out.
Pair up. Let's go. Let's go.
That's the 4 No, I was still on it too,
Yeah, no, I'll clear it too.
Hey, you're right.
What'd you do after you multiplied?
Because you're trying to find Q, so all you have to do is
Multiply 25 times 20 times 8.
25 times 60
Oh, I didn't do that.
times 12.
Yeah, I didn't do that. I did it wrong.
No, I think I just spent it.
Hey, what are you doing, dude?
So bad.
I'm not happy with it.
Okay. Split apart. You didn't really actually talk to each other, or did you?
Yeah, we did.
All right.
I'm like,
This 25 comes from right here. That's the mass of the water. It's grams. 4.18 comes from table B. That's specific heat. Delta T, it's always final minus initial. 80 minus 20 equals 60 degrees. It's always final minus initial. That's how we do this. Now what do? Plug it in. Q equals 25 times 4.18 times 60. Multiply all three numbers, and who has an answer? Kristen.
6,270
270
J.
joules. Positive because our energy change was temperature change was positive, so it's endothermic. The water's absorbing heat, getting warmer. Okay? So tomorrow, don't pack up. Tomorrow you're gonna be doing 2 worksheets like this. I'm not gonna be able to get to the boiling water because it's not boiling
Can I
yet.
stick my hand in it?
Well, now you probably could. It's not hot enough. But we will do that Monday. Here's your quizzes. Now, if you get a raffle ticket on your quiz, that does not mean it's a good thing. It means you have to see me. So I'm trying this new thing here this year. That if I write "see me," you get a raffle ticket and I get one, and I write your name on it, so I know you're out there because I have the ticket. I tend to forget who I say "see me" to, and the kids never come see me, and they never get the information they need. It's not a punishment. It's not mandatory either. I'm not going to write you up, but I really highly suggest it. So I'm trying it this year.